All right, in today's notes, we are going to be talking about parallel and perpendicular lines. So in these slides, these are two parallel lines. I know that because they will never intersect. No matter where we go on the graph, they are the same distance apart. And the reason why, if you look at these lines, we have a slope of 3 and a slope of 3, and then the y-intercept is different. So the same slope, different y-intercepts would make two lines parallel. Same with here. This is really a -1 slope, and then this is a -1 slope. So parallel. +1/3 for both of these slopes, which makes it parallel. So what is the same? The slopes. What is different? The y-intercepts. Now on these slides, I gave you an equation that is already graphed for you. And now it says we need a parallel line that goes through that point. So parallel lines, all you need to know, that's a parallel slope, is the same slope that I gave you. So I gave you -1/2. And then the given point right here is 4, 3. So we are going to use the point slope form to plug it in, and then I will show you the extra work that we will do to get it in slope intercept form. So this part is nothing new. Our y1 is 3, our m is -1/2, and then x minus 4. So notice that it says slope intercept form. So what we need to do from there is distribute, and you're always going to distribute. And then the next always is always going to undo. So we have y equals -1/2 x plus 5. So if you type that in, make sure the x is on the side. It is parallel and it is going to go through the point. That's how you know you're right. Same thing here. I have this line graphed. It's 2x. It's already graphed for us. But it says we need to graph the parallel line. Parallel is the same slope. And then goes through that point, which is -1, 4. So we're going to do the triple substitution. And then just remember, minus a negative is really adding 1. So then distribute. And then we're going to add 4 because we're going to undo. So 2x plus 6 is going to be our parallel line that goes through that given point. It's parallel because I know that the slopes are the same, and then it crosses through the given point. You can do the next slide on your own. The last type of lines we're going to talk about is perpendicular. Now, perpendicular, we have a fraction here. We have 2/5, but then the perpendicular slope is the opposite. So this was really a positive. Now it's negative, and we flip it. It's called reciprocal. So the slopes are opposite reciprocals. Same with here. I start with a negative. My perpendicular slope will be positive. I started with 4/3 and I flipped it to 3/4. So you have to do both of those. So their slopes are flipped and opposites. And then we honestly don't care about the y-intercepts. They could be the same or different. So we are really just concentrating on the slope. Here, I have the slope of -2, but I need the perpendicular slope because that's what the equation, or I'm sorry, the word problem says to do. So if I start with a negative, then I know I need to make it positive. And then I have to create a numerator and a denominator and flip it. So I don't need the original slope. I now need the new perpendicular slope. And then I need the point given. So the point given is 4 comma 3. And then you treat it just like we did before. So y minus 3 equals a positive 1/2 x in parentheses and then minus 4. And then we can distribute. And then it's a one step like always. So here our slope is different. That's the only thing that we have to remember. We have to do the opposite sign, and we have to do the reciprocal, which is flipping the number. And then slide 18 is just the same. We have our original slope, 4 over 3. We need a perpendicular slope because it says perpendicular. So I started out positive, so my perpendicular slope will be negative. And then I have to flip the numerator and the denominator. Once you do that, we're done with the original slope. We can now look at our point negative 4 comma 6 and then plug that in. Y minus 6 equals negative 3 over 4x. And then be careful, minus a negative is positive. And then we're always undoing. So just by entering negative 3 over 4x, you can see that this is in fact a right angle because it's a perfect 90 degrees, but it doesn't go through the point yet. So you can do the y-intercept that we found over here, and then that would get you the perpendicular line that goes through the point negative 4 comma 6.